Good morning, Electric Culture of Safety Line Team. Welcome to episode 067. Our buddy here and line brother, Mr. Mark Forster, he's going to be talking today about the power of preparation. And it's going to be really great. His other three presentations were wonderful. Just a couple of quick announcements. North Dakota Rural Electric Cooperative Association, they have thrown in their logo into the ECOS partnership logo, and we appreciate the folks from North Dakota jumping in, and they're going to be sharing these webinars. After tomorrow, we'll have 68. They're going to be sharing these webinars from time to time, segments or in full, to all their line folks in all of North Dakota. So we're excited about them jumping on board and partnering up with Electric Culture of Safety. And we also have another deal. We've eclipsed over 14,500 partners that have registered, and they're receiving these every single month. They get both Linemen Safety National Webinars. We do 2 a month now, and they receive both for absolutely no cost, and they share those. And also just more and more of the influence of what we're creating and fostering as coming together as a nationwide line team and sharing all of these episodes and topics. Amazing. It's just amazing after 3 years now. So Mark, real quick, the Substation Craft was his 026 episode. Mark was here sharing that. That was his very first one. That was back in 2023, Mark. Isn't that crazy? 2023. And then we have Structured Practice, which I really like that one as well, as far as structuring and putting together the training. A lot of details that he shared in that. That's a really great one. And that's going to be 047. And then Back to Basics, Electricity 202. It's a great video to go over all of what he spoke about regarding the basics, and it's just a good refresher. And actually, I learned some things myself, so it was like, wow. So anyways, Mark, appreciate you coming here.
For sure.
Appreciate you,
Glad to be here.
your visit.
Yes, sir.
And Mark and I had a nice dinner last night talking about training, talking about getting out there and the resources that it takes to give to our crews, our line crews, and how there's this vacuum of folks that is happening right now, and it's actually kind of hard to get these trainers. And the trainers that are out there, we were talking this morning again, they are busy training all around the country. And Mark, give us a little bit about what, you don't have to mention any names, but kind of some of the projects that you all are working on now. I know you guys are busy.
Yeah, so we got a lot going on. Have gotten really busy here midway through the first quarter. It looks like that's going to continue. We're doing, so one of the things we've started to focus on is developing partnerships, you know, similar to what we're doing with ECOS and everybody there, but we are partnering with some associations around the country to bring training to their member groups.
Yeah.
So that's a big thing we've been working on. We still do our 2-day training, 1-day training, 3-day training, right? And so on everything from live line bare hand is a big one, bucket and pole top rescue, grounding and bonding. So the staples that everybody is looking for are still the staples. And so yeah, it's just something that we need to continue to do, right? Things evolve in our world very quickly, and we need to keep our people up to speed so that they're competent out there in what they're doing.
Right.
Can't stress enough how training and competency goes to eliminating incidents and accidents, right?
Yeah.
And that's the whole key is sending our people home, the same way they came to work, so that they
Exactly.
can enjoy what they do outside of their work life. So, yeah.
Yeah. Well, folks, Institute for Safety and Powerline Construction, they share probably 6 or so presentations every single year. So they are the biggest contributor to electric culture of safety, and they give back. And I know that ISPC, you all also write curriculum. You also write programs as far as the training programs and work methods as well.
Yeah, so we do a lot of procedure work, usually a couple a year. We have some companies that want us to do all the work and write all the procedures and marry them in with their safety manual and those type of things. We have some that just kind of want our overview, and they do the work, and we kind of make sure they're going in the right direction. We are obviously, our line curriculum is T&D Power Skills, right, which is our sister company. But then the need, so when I came on board full-time back in the end of 2023, I started developing a substation apprenticeship curriculum. So 48 courses, it'll be a 4-year program.
Nice.
You can also structure it as a 3-year program. I think in some cases that's a little aggressive. I think, we need our apprentices need the time to grow, right? And so we got to watch we don't shrink that too small, and start getting people into positions where they really aren't competent yet, right? They might understand the theory,
right?
But I think they need more time in the tools to make sure they are at that competency point. And then, so, we have the substation curriculum that we're building. We have a telecom curriculum. We have a metering curriculum. We have a transmission curriculum. We're looking to develop a relay curriculum for relay test folks. And so, yeah, a lot of good stuff coming when it comes to curriculum that you'll be able to use. They're all can be DOL certified. And so, yeah, some exciting things coming.
All right, folks. Well, welcome aboard, and just pay attention here. Doesn't cost anything to pay attention. Mark's going to be sharing a lot of information, a lot of line wisdom, and appreciate you coming here, brother.
No problem.
Okay.
Always a pleasure.
You bet. Thank you.
All right. Good morning, everyone. So the power of preparation, and really what this is as I travel around and work with line crews around the nation, I recognize that maybe we're not preparing for the day or for the job or the task at hand as good as we should be. So I work to put this presentation together so that we can take a look at everything we should be touching on and talking about when we're doing our job briefings, right? And so this is really setting you up for success when it comes to how am I going to attack my work for the day, and making sure that we're talking about everything we need to talk about. So a couple of those things that we need to understand about this whole process, right? So number one, safety is everybody's responsibility, okay? So I don't care if you're that first-year apprentice or you're that 35-year journeyman, even supervisor for that matter. Everybody involved in that team for that job, it's their responsibility to make sure that not only themselves, but everybody they're working with has safety at the forefront of their mind that day, right? So that we can all add value and be involved with the safety of the job for that day. The job briefing, one of the best tools that we can use to prepare for the job, right? And a lot of things we do with the job briefing, identifying hazards and mitigating hazards and those type of things, and we'll talk about that more as we go through. But again, the job briefing is everybody's responsibility, right? If you're a work crew out there and you have one individual that's sitting in the truck filling out the job briefing while everybody else is getting tools ready and preparing for the job that day, you're missing the mark, right? You're just not doing yourself any favors. And so we need to change that, right? The job briefing should be a conversation with every single person that's going to be involved with the job that day. Thinking out loud, right? And so this is the ability of everybody involved in the crew that day speaking up and talking, right? Giving your input to the job briefing, how the job goes, if you think something isn't going correctly, being willing to verbalize that and talk to your fellow workers and say, hey, hold on here, something's just not right. Let's stop, let's talk about this, right? So, if we're keeping those things in and not sharing that information, again, we're missing the mark, right? Couple more here. So we'll talk about hazard analysis, right? And so, obviously a big piece of our job briefings is hazard analysis, and being able to look at the job tasks we're going to do and try to predict, is there hazards we're going to face in that job, right? Is something hiding there that could jump out and bite us, right? And identifying that and talking about it and make sure everybody's on the same page. And so we'll touch on that as we go through here. Already talked a little bit about good communication, but I think a lot of times when we communicate out on the job as a crew, we tend to assume, because we're working with similar level folks, right? We tend to assume some things, so we may not communicate as well as we should communicate, right? We may say things and assume that the person we're communicating to will fill in the blanks with the rest of it, right? And that's going to get us in trouble. So we got to work at being better communicators and making sure that whoever you're conversing with truly understands what you're trying to tell them, right? And then the last one, and maybe the most important one, when everything else we just talked about doesn't work as it should, we have that stop work authority, right? And that's the ability for anybody on the crew to say, stop, something's not right here, we need to regroup, we need to talk about this, and figure out how we need to proceed from there, right? And so again, it's probably the most important part of the workday, is knowing that you have the ability, at no matter what level of your career you're at, apprentice all the way up to seasoned person, to say, stop, something's not right here, we got to figure out what we need to do to move forward. So all right, so OSHA tells us that prior to every job we need to do a job briefing, right? Everybody knows that, it's no secret. But there's the difference between just doing the job briefing because we have to, and doing the job briefing the way it should be done, okay? And we're going to talk about that today, okay? The employer must ensure that the employee in charge conducts that job briefing, all right? And that doesn't mean that employee has to conduct the job briefing. They just need to make sure that it is conducted properly, no matter who's doing it, right? And I would challenge you to not always have that senior person doing the job briefing, right? Let your apprentices do the job briefing. It's how they learn, right? And it's how you gain trust in your coworkers, right? As they mature and get better at doing the job briefings, you'll gain more and more trust that they know what they're doing out there on the job. I can't stress that enough, right? And then the last thing OSHA tells us is that there's 5 things that we need to include on that job briefing, right? The hazards, the work procedures, right? The special precautions, our energy sources, and our PPE. Now this is minimum, right? I would argue that there's a lot more we can go over, right? There's a lot more that we can go over when it comes to job briefings, but this is the minimum that you must cover. And then the one thing I want to talk about today that I don't think we talk about enough is what happens when the plan doesn't go as planned, right? In our industry, we stress so much about developing that plan and building that plan and talking about what hazards we may incur that day, the work procedures that we need to follow, our PPE, so on. What happens when that doesn't go as planned? have we talked about in the job briefing what each individual person needs to do when the unexpected happens, right? And I don't think we talk about that enough. We're not prepared for that, right? You know, if you have people climbing, right? What happens if one of them has a medical issue on top of the pole or in the bucket? Do you know how to operate those ground controls to get that guy to the ground? Do you know what you're going to do? Do you have your rescue equipment ready should something go wrong, right? And so I'm going to touch on that multiple times today. So a couple things that go into helping us through our daily job, right? And so I want to touch a little bit on human performance, okay? Because human performance plays a big part in how I interact with the crew and the work, right? And so the definition of human performance is the principles, practices, and science of understanding and improving individual and team performance, right? So we need to understand how our people are going to react to certain situations. We need to understand, you know, how, if something goes wrong, what is that individual or how is that individual going to react to that, right? And this is particularly important when we get into high-risk environments. Well, a lot of the work we do is in high-risk environments, right? And so the other thing human performance does is it focuses on minimizing errors, enhance reliability, and ensure safety, right? And so there's certain things we can do as we're working to make sure that we are keeping ourselves safe. Now, some principles of human performance. First and foremost, people are fallible, right? So I have countless examples, and I'm not going to get into that today, but I have countless examples of incidents or accidents that have happened throughout my career with other co-workers. And a lot of times it's not the inexperienced apprentice that has the incident, it's the experienced person that has a mental block, skips a step, gets complacent, whatever the case may be. But the bottom line is we all can make mistakes. I don't care how much training you do, how much experience you have. If your head is not in the game that day, you're setting yourself up to potentially have an incident, right? The other thing that we know, and most of us have heard throughout our career, is error-likely situations are predictable, right? So that's that part of that hazard analysis, right? And understanding what's going to, or what potentially is going to jump up and bite us during a job, right? And we can manage those, and we can also prevent them by taking certain steps. We can prevent those error-likely situations, right? But first, we got to identify them. We got to know they're there, okay? Individual behavior is influenced by organizational processes and values. So essentially what this is saying is that based on the organization's procedures and values, they can almost be setting you up for failure, right? So sometimes it's not how we behave, it's the process that has been established by the company to do a certain task could lead you in the direction of having an error, right? And so we got to understand that. And sometimes when things don't go wrong or don't go right, we look to find fault in a person, right? Okay, what did somebody not do or not think of, right? But in some cases, it's not the individual. It's the organization and the way their work methods have you doing work. And so sometimes we need to take a step back and not just always look for blame in the person or in a person that has had an incident, right? So I think where every company wants to be is at a point where these opportunities or these incidents are opportunities to learn, right? So if you're always, when an incident happens in your organization, if you're always looking to identify who made a mistake or what went wrong, right, we're missing the boat, right? We need to be at a point, and we need to have a culture where when something bad happens, let's figure out why and let's learn from it so it doesn't happen again, right? Not just cast blame to the person that made a mistake, okay? Human performance is shaped by how work is designed and executed. So again, back to this kind of process or procedure, we can again be doing work and doing things that we normally wouldn't do because of how we have to do the work, right? And so those are things we need to figure out as organizations and get those out of our work methods and work processes, okay? So I'm going to just go through some human performance tools, and a lot of these people are already doing, right? We just put fancy names to them, right? So, you know, self-check, right? That's you as an individual before you're ready to do a task, taking that quick moment to say, all right, what's going to happen when I do this, right? What's the outcome going to be? You probably do it hundreds of times a day already and don't even think about it, right? And so we're just putting a name to it, right? And then on the flip side, a peer check, okay? So this is your buddy or your coworker, right? Doing that same pause to make sure and agree with you that what you're about to do is correct, okay? And with that peer check, that second person has just as much responsibility to make sure that what you're about to do is correct, right? Whether you're switching or you know, whatever you're doing, okay? We already touched on stop work authority, and we'll talk about that more as we go through here, but a very important, arguably maybe the most important human performance tool, because when all else fails, this is the last opportunity for you to say stop, right? This is that see something, say something, okay? If you see something and you think it's not right, don't blow past that and just say, I ought to be okay. Stop, right? Stop the work and talk about it, okay? Situational awareness, right? Understanding what's going on around you, right? A lot of times when we're working, we get focused, right? Laser focused on the task we're doing, and we forget about what's going on around us, right? Is what we're about to do going to affect other people in your work area or your work zone, right? So it's understanding not only what we're doing, but what's around us, what's going on, and being, you know, recognizing that, being aware of that, okay? Questioning attitude, right? Understanding what's going on, and knowing what's going to happen when you do something, right? And if something doesn't seem right, questioning it, right? Asking, what's going on here, okay? We talked about communication earlier. You know, a good way to establish that clear communication is through three-way communication, right? And it's kind of that confirmation that the person you're talking to understands exactly what you're trying to get across, okay? We talked about procedure use, or touched on that. But it's following those company procedures for the work that you're doing, right? Rather than just going at it or trying to go at it from memory, and then we end up deviating from that process, right? Sometimes intentionally, sometimes not intentionally. And so it's understanding that when we're doing work that has procedures involved with it, that we're following those procedures, okay? And then again, back to the job briefing, right? All this kind of comes together with the job briefing. Everything we've talked about so far this morning should be stuff that's incorporated in your daily job briefing, okay? And then the last two human performance tools, critical step, right? So this is that step prior to what we call the irreversible step, right? The point when you make the switch move or you make the decision to do something that once done, you can't take back, right? The consequences are inevitable, okay? And some of those critical steps, if performed incorrectly, become the basis for those incidents or those error likely situations, right? They kind of set you up for failure. It's not the last stop. We always have that stop work authority, right? To say right before we do that irreversible step, hey, hold on, something's not right here. Some easy examples to kind of put together with these critical steps, right? So aiming at the proper target, right? If you're going to, if you're going to shoot a gun, we got the critical step is make sure you're aiming where you're going to shoot, right? Identifying the proper device when you're switching, right? If you're on the wrong device, what's going to happen when you open or close it, right? Something you don't want to happen, okay? Looking both ways before you proceed, right? If you're at that intersection and you don't look both ways and you just pull out, there's a good chance you're going to get hit, okay? And then the last one is this irreversible step, right? So this is, again, the point of no return. If once this step is performed, the consequences are immediate. Either the right thing's going to happen or the wrong thing's going to happen, okay? And so everything we've done leading up to this point is to ensure that this step, you get the result that you want, right? Not the incorrect result, okay? And so again, following from the critical step, right? The critical step was aiming the gun. The irreversible step is pulling the trigger. Once you pull the trigger, the bullet's not coming back in the gun. It's going to hit whatever you're pointed at, right? If you're switching and you're opening and closing a device, if you're on the wrong device, you're going to open or close the wrong device, and so on. So, again, once these actions are performed, they can't be reversed. Whatever the consequence is what it's going to be, okay? All right, so let's switch now to task hazard analysis, right? And so this is a systematic process used to identify hazards, okay? Now, once these hazards are identified, then we can start to ask ourselves, what's the risk with this hazard, right? Is it something I need to be concerned about? Is it something I just need to be aware of, right? Do we need to develop control measures to deal with this hazard? Is it something we can mitigate, or is it something we can eliminate, okay? And then these couple questions will then help you understand what you need to do to manage that risk, okay? So I'm sure most have seen the energy wheel before, okay? Used to ensure that no sources of potential are missed, okay? Now, not only, and I think sometimes where we may go astray is, this doesn't just pertain to the task you're about to do, right? But it also pertains to the environment around you. It pertains to the tools you're going to use, right? So I think sometimes where we get led astray is guys or crews will identify the hazards based on this energy wheel for the work or the task they're going to do, and they don't look at it, right? This pertains to driving to the job. This pertains to loading material at the shop before you even go to the job. And I think we tend to focus with this more on just the task we're doing at the job, and we need to look at it holistically. So, when we're talking about, hazards, again, we're loading poles in the pole yard before we even go to the job. Have we even done our job briefing yet for the morning at this point, right? Or are we doing our job briefing once we get out to the actual job, right? And so if that's what we're doing, we're missing an opportunity here, right? We're not making people aware of what's going on, right? When we're doing our task hazard analysis, are we talking about our vehicles, right? Have we done this analysis on the tools and the equipment we're about to use? If we're not, we're missing the boat, okay? Have we talked about weather and the environment, right? If you're doing cable pulling, right? Are we just concerned with the cable pull itself, or have we identified potential hazards that could have problems with the equipment that we're using, right? So we got to be talking about everything when we're talking about task hazard analysis. It can't just be about the actual work, okay? Everything there is involved. And then once those hazards have been identified, then we got to determine again what level of risk is associated with that hazard. Is it something that we just need to know for awareness again, or is it something that we need to take specific steps to prevent that hazard from becoming an issue in our work area, okay? What are the consequences? So if this hazard that we have identified comes to light in our work that day, what are the consequences? How severe are the consequences, right? And then this will help you determine whether or not you just need to mitigate that hazard, or do we need to look to try to eliminate that hazard, right? Is the risk severe enough that we don't even want to take the chance that it shows up in our work for the day, okay? So we then look to control measures, right, to eliminate or mitigate these hazards, okay? And I'm sure everybody, again, has seen the hierarchy of controls, right? But this is a way that we can look. Obviously, the most effective is being eliminating the hazard, all the way down to the least effective is PPE. And I think a lot of times, this tends to be our first choice. We'll just wear our PPE and we'll be good. That should be your last choice, right? Kind of a good saying to live by is, always use your PPE, but never need your PPE, okay? All right, documentation, right? We use our job briefing to document the findings of our hazard analysis, right? And we list them on our job briefing, the hazards that we may run into, you know, based on the tasks we're doing. What are the hazards? What's the risk? And then what control measures are we going to use to mitigate those hazards? And then the last and probably most important part is communicating that to our workers, right? Making sure that everybody in that group, and again, like I said earlier, here's kind of where we can start to go wrong if we got one individual doing that job briefing and then kind of just communicate, hey, today we're going to do this, here's some of the hazards, here's how we're going to prevent those hazards. Everybody agree? Yeah, I agree. Do they really agree? Do they really even understand what you're talking about? And so that's where that group discussion is so important, to make sure that everybody is on the same page and has had input into the job briefing. Again, I brought this up once already. What happens when this plan doesn't go as planned? Are we ready for that? Okay. Have we talked about, or do we have the tools and the equipment available and ready to take care of this issue? A couple weeks ago, I was doing some fall protection training, and this kind of hit me. You know, you wear your harness and you have your lifelines and you have everything in place to make sure that the job is successful. But what happens if somebody falls? What happens if something happens that you're not thinking is going to happen? Are you prepared to act on that, right? Have you discussed that in your job briefing so that everybody knows what part they play in that action when something doesn't go as planned, right? And if you haven't talked about that, you're missing the boat, because the individual who was had the accident or incident or whatever is going to suffer longer than they need to until you figure out what you have to do to get them down out of the air or whatever the case may be. So we need to be discussing this at our job briefings, okay? All right, so I touched on this a couple times. Are you having these group discussions, right? I can't stress the importance of making sure that everybody that's working that job that day has the opportunity for input, okay? Or to ask questions, or to question the method, the work method, whatever the case. So important. Listen, everybody, I don't care if you've been in this industry for 30 years or more, right? I've been in this industry 25 plus years. There's stuff that other people know that I don't know. Not everybody has been exposed to every type of work that we do in our industry, right? And so you could have an individual on your crew that day that has done the exact work you're going to do. And maybe it's been a while or maybe never since you've done that work, right? So that's the importance of ensuring everybody has input to the job briefing, right? Experiences, right? Collaboration, consensus, right? Making sure everybody agrees with what we're going to do, not just that head nod. Yeah, okay, I'm okay with that, right? Frequency of exposure, right? So how often we are exposed to a hazard can elevate the level of that risk, right? So if we're going to do repetitious work, right? The more we do that repetitious work, the more susceptible we are to having an incident, right? If you're lifting something heavy, right? Say you're going to pick up a box and you're moving boxes all day, right? The more boxes you pick up and move, the more likely chance is you're going to throw out your back or have something go wrong with your body because of the work you're doing, right? And so the more frequently we're exposed to that hazard, the greater chance of incident, okay? The other thing that tends to happen when we're exposed to hazardous conditions frequently is when nothing happens, nothing goes wrong, right? We do the task, there's hazards involved, we complete that job incident-free. We as human beings, right, tend to lessen the risk involved with that task. I've done this 100 times. Nothing ever has gone wrong. So our risk level now comes from here to here, okay? And then, because we're being less vigilant about that task, that's when things start to go wrong, okay? All right. So we touched on stop work authority several times already as well. There's a difference. So and this is something you can ask your least experienced workers, right? Or your apprentices. Do they truly feel that they can stop work? Or are they just being told they can stop work? There's a difference, right? And so, being able to stop work without negative consequences, right? Or being made fun of because you stopped a job, right? And, oh, you don't know what you're talking about. Don't worry about it. Just keep working. We'll be fine, right? That's a big difference. And it plays a strong role in the safety culture you have within your company, right? See something, say something, right? I can't stress it enough. If you feel something is not going right and you see it, you got to say something. Speak up, right? If you don't, that could be going down that pathway of having an incident. Okay. So essentially everything we've talked about so far goes to this plan the work the plan, right? And then we got to reassess. And this is tough for a lot of people, this reassess part, right? So this is as the job's going on throughout the day, we're making sure that we're still following the plan. We're making sure that everything that we're doing is following that plan. If you have trouble doing that, schedule some breaks into your day. Schedule some intentional breaks into your day to be able to take 5 or 10 minutes and stand back and say, all right, is this going the way we wanted it to go? Or is it not? Do we need to reevaluate and figure out a new path forward, right? Again, what happens when this plan does not go as planned, right? We need to be ready for that, okay? All right. So I didn't touch on one part of the task hazard analysis because I feel that there's oftentimes when we're talking about grounding and bonding, it's just what we do, right? We don't necessarily associate hazards with grounding and bonding, right? We're installing grounding and bonding for our protection, right? Not to prevent a hazard. Well, that's not exactly true, right? So the way that we install our grounding and bonding can be introducing hazards into our work zone that we're not even aware of, right? Unless we understand them. And so I'm going to dive into this grounding and bonding and task hazard analysis a little deeper than I did the work, right? And so, you know, a couple things just from OSHA that we need to be doing, right? So before we're installing that grounding and bonding, you know, we need to make sure that we test for absence of voltage, right? That's a given. I don't know anybody that wouldn't do that. It's a process we follow. It's making sure that that line we're about to install that ground on is truly dead, right, or de-energized, okay? OSHA also tells us that the employer shall ensure when we attach a ground that we do the ground end first. One of the things that I have seen though is once this first ground is attached, guys feel that they can go put those remaining grounds on with their rubber goods, with their PPE, right? They don't need to use a stick anymore because the line's already grounded. And that's not exactly true, right? We should never handle the unconnected end of a ground, right? Yes, the likelihood or the chance of a fault or something happening at the moment we're connecting that ground is very slim, but you're still playing the lottery, right? So we should always make the ground source connection first, then we go to the closest phase and so on, right? And we should always be using a hot stick, right? The other thing that I see a lot, and I've done it in the past when I was working, is, right, one guy's operating the stick to put the grounds on and his buddy's grabbing the ground clamp end and sticking it on the end of the hot stick for him, right? And does not have any PPE on, right? Is just doing it with, you know, bare hands or leather gloves. If an incident should occur at that exact moment, you're putting yourself at a high risk of having a problem, okay? So, when we're installing our grounds, okay, so this first safety principle, current flows in every available path inversely proportional to the resistance in that path. That includes the grounding that we're installing on the system for our protection, right? So every ground that we install becomes another pathway for current to flow in our work zone, okay? And so it's understanding that, that when you install a ground, right, you're going to collapse the voltage. However, when you install the second ground and the third ground and the fourth ground, you are creating pathways for current to flow. And so whether the hazard is induction or whether it's a fault, right, if you have that pathway, current's going to flow. You can also be one of these pathways depending where you're putting yourself in the work area, right? And so based on your internal resistance, that'll determine how much current's going to flow through you. Are we talking about this when we're doing our job briefings, right? Are we talking about these hazards, right? Here's a perfect example. You are introducing a hazard into your work zone intentionally. And do you understand that? Do you recognize it? Do you talk about it, right? And so, you know, here's just a quick example. If you'd have, you know, this is 7,200 volts. So if you'd have a fault, or, you know, if you're working at higher voltage levels where induction is an issue, right? Based on the resistances in those paths, right? So the number that the industry uses for the internal resistance of a human being is somewhere between 100 and 1,000 ohms based on conditions, right? If you're sweaty and all that, that tends to get down closer to this 100. But the average number is 1,000 ohms for the internal resistance of the human body, right? And so if 7,200 volts, if that voltage breaks the resistance of your skin and current flows 7.2 amps. Could be less, could be more. This is just kind of an example. It's all going to be based on system conditions and fault conditions and so on. But that's obviously enough to kill us, right? Are we talking about this when we're doing our job briefing? Do we recognize this as a potential hazard? I don't think we do as much as we should, right? All right, safety principle number 2, if you insert a resistance in a current carrying ground to conductor, a voltage rise will appear. Again, that voltage will be proportional to the resistance in that path, okay? And so, if we have a true open, we're going to have full voltage across that open, right? If you get yourself across that open point, that's what you're going to see across your body, okay? Well, you're not going to see 72, you're going to see something less because you got to minus your resistance out of there, right? And so that's why we bond, right? We bond across those resistances so that that voltage is as low as it can be, right? And then the last safety principle is it takes approximately 50 volts to break the resistance of your skin, okay? Once that happens, current's going to flow in your body, okay? Again, are we talking about these things? So we often talk about grounding for the protection of personnel. You hear it all the time, right? Even OSHA says it. Grounding for the protection of personnel. Well, the first thing that we need to recognize is grounding is not for personal protection. Grounding is for tripping, right? For activating relays and tripping. That's the purpose of grounds, okay? When we talk about protecting personnel, we're referring to bonding, right? Eliminating those differences of potential in the work area, okay? And so it's important that we understand we can install our grounds in an equipotential fashion and protect our workers, but not always can we do that, right? And it's understanding that. The other thing we got to understand is while grounds do play an important part, right, in keeping a conductor from becoming energized, right, tripping those relays offline, the problem is that all grounds are not equal, okay? And so if we have grounds installed in our system of different resistances, whether it's because they're different lengths, whether it's because this ground has been exposed to environmental conditions and such that has raised the resistance of that ground conductor. If we have different resistances here, and now because we have 2 grounds installed, we have created that pathway that current can flow. If voltage is there, current can flow. We end up with differences in voltage in our ground paths, and that becomes a hazard to us if we get ourselves in the wrong position there, right? Again, are we talking about this as a hazard in our job briefing? Probably not, right? Every job briefing I've ever been involved in, when I'm actually out working, we're talking about putting grounding and bonding on for our protection, not creating hazards in our work zone, right? And so we're not talking about this stuff. And a lot of times we get away with it because of the way the system is built, right? There's incidental grounding that's always there because of the way the system is built, right? And then we intentionally put grounds on for our protection, right? So there's a difference between the two. But the one key thing to understand is that, here's an example of bracket grounding, right? Well, by bracket grounding, we just created a pathway for current to flow. Should there be a fault or induction or some sort of voltage source that is in the system that we're working, okay? The other thing, we can't predict when a fault's going to happen, right? And not necessarily does this fault have to happen right here in your work area, right? The fault could happen around the block, down the street, right? The neutral is connected everywhere in the system. So it doesn't matter, right? If you have a fault down the street, you could have an open point here on your energy or your conductors. So you could have an open point on both sides of your work area. If that neutral is still attached, that neutral is tied in the entire system. Current flows in the neutral. If you have a fault, you're going to see current in your work zone. Have we talked about that? Do you guys understand that, right? And so that's the importance of talking about this when it comes to hazard. Again, this is just another way to look at it in kind of a little bit different light. You know, we have our pole bonds, neutral, phase conductor, right? Bracket grounds installed. Us working in here, what do we look like? Just another bracket ground, right? We're just another pathway in this work zone. So if a fault occurs outside of our work zone, right, neutral still connected, we have a current pathway here, and if we're part of that pathway, we're just going to be another parallel path in the division of that voltage and current that's going to flow in that work zone, okay? So if that fault occurs, it's going to be flowing everywhere, right? Okay? When it comes to our temporary grounding systems, these pole bonds should not be part of our temporary grounding setup, right? What are they? Number 6 copper, most cases, right? 2-aught copper grounds. These are not going to handle the current that your temporary grounds are going to handle, right? This is what we call incidental protection, intentional protection, right? We're intentionally installing these for our protection, and then relying on incidental grounding to also help us with our intentional grounding, right? And so, just like with anything, this is going to be the fuse link, right? The weak point in our grounding setup, right? So if we flip over to equipotential grounding, right? Now the only thing we're doing different here than what we did on the previous screen is we're bonding the pole to our work area. It's the only difference, and then we're intentionally bypassing that pole bond so that our entire grounding setup is equal. We're making all our conductive pieces, which the pole is conductive, does have some conductive properties. We're making everything one voltage potential, right? And so this is intentional. We're using none of the incidental grounding there to rely on our protection. It's all intentional, okay? And so this is what we've supposed to have been doing since back around 2015 and actually before that, okay? Same thing if you're working on a switch, right? What's the hazard here, right? Where's the hazard? Well, if we put our grounds out here, again, bracket grounds, and we normally put our grounds out here, why? So they're out of our work area, right? They're not in our way when we're trying to work. But do we understand, and are we talking about the hazard if, again, a fault should occur or we should have induction in this work area, right? What hazards do we introduce? Well, say we have an induction source from over here, right? Now we've created a pathway for current to flow, and at this open point between the switch, we have the potential to have a hazardous voltage appear, right? So normally what are we doing here? We're working on this switch, right? And in most cases, what most guys are going to do is they're going to bring this blade down to about here so they can position their aerial equipment and work on the jaw connection and the contact connection at the same time if we're overhauling this switch or whatever we're doing, right? Well, now you just brought this voltage from here down to here, right? Are we recognizing by the way we install our grounds, and if we would have a fault or if we would have induction in our work area, do we recognize the hazard that's right here where we're working? Are we talking about that? Are we identifying that as a hazard during our job briefing? In most cases, I don't believe so. And then do we understand what we can do to get rid of that, right? So instead of, not that you can install these grounds, but if we bring them in here and bond everything to the same ground connection, we can eliminate that hazardous difference, okay? Just a kind of another way to look at it, right? We're not quite equipotential here, we're close, but there's that potential difference here, right? That could be hazardous, may not be, depending on the system conditions. But if we move our grounds in here, we can truly equipotential and remove that hazard, okay? Are we talking about this? Are we preparing ourselves for this when we're doing our job briefing, right? Have we identified this hazard by the way we install our temporary grounding, which we think we're doing to protect ourselves, okay? Same thing when you bring an aerial piece of equipment into the mix, right? Are we bonding ourselves into that work area, or are we not, and we're setting ourselves up for a potential hazard, right? All right, so when it comes to equipment grounding now, right, OSHA tells us that we have to protect from hazards that might arise from equipment contact, right? So what do? What does the safety department tell us we got to do? We got to ground our equipment. Okay, we're protecting our people. Our equipment's grounded. No, that's not the case, right? Grounding a piece of equipment that's up working energized or near energized facility does not protect the people in the air or on the ground, especially on the ground, right? Because what's going to happen if that grounded vehicle, right? What's going to happen if this aerial lift gets into energized facilities up here, right? The grounding of this piece of equipment is so that if this does get into energized facilities, again, it trips the relays and eliminates the voltage as quickly as possible within a couple cycles, right? The problem is with this vehicle grounded, when this gets into energized facilities, now your voltage is coming to the ground, right? And so now you got to ensure that your people on the ground understand that, and you're protecting them through barricading, ground mats, keeping people away from the equipment on the ground. But again, are we talking about this hazard that we are intentionally developing by the way we install our grounding and our bonding, right? Are we talking about that in our job briefing, right? And so the other thing we normally do is when we ground our aerial lift, we tend to ground it away from where we're working so that we can move our equipment around and not run over our grounds or have to have somebody on the ground following our ground connection around. The problem in lies is normally what we're up working on may be grounded at a different structure. So what does that do? Right here at this point, it creates the potential for a hazardous difference in potential, right? And so we need to bond into that work area to eliminate that hazard. Are we recognizing that? Are we discussing that in our hazard analysis process when we're doing our job briefing, right? A lot of times I don't think we are, because we used to do this all the time and we just assumed it was a product of working in a higher voltage environment. What we didn't understand was this is a difference in potential, right? And so we need to understand that and talk about it, okay? So, a couple things when it comes to grounding. Understand the sources, right? We need to be talking about these when we're doing our job briefing. Understanding where the voltage and current can come from if something should go wrong in our grounded work area, okay? Understand the paths that are available. Every ground you install or bond that you install in your work zone for protection is a pathway if something goes wrong, okay? So are we identifying that and talking about it? understand how we need to bond in or isolate or insulate yourself to protect you. We need to be talking about this when we're preparing and going through our job briefing, okay? And then understand the limitations of your methods, right? What you've installed, understand the protection that that provides you and when that protection is no longer going to be good, okay? So finishing up here, I hear this all the time, right? Be your brother's keeper or your sister's keeper, right? So I couldn't agree more. The one thing, though, that we need to understand, before you can be your brother and sister's keeper, you got to be your own keeper, right? And so everything we talked about today, if you can't individually identify that stuff and recognize those hazards, one, you're not keeping yourself safe. Two, you can't keep anybody else safe, right? If you don't understand what's going on out there in your work zone and you're not prepared for the unexpected and so on, and identifying those hazards, you can't keep yourself safe and neither can you keep your brother and sisters safe, right? So we need to understand that. Again, I'll say it probably for the 6th time this morning. What happens if something doesn't go as planned? Are we ready to address that and understand what we need to do, right? Be prepared for the unexpected. You never know. You can plan as much as you want. There's always going to be that one thing that you missed identifying, or it could be an external issue that is just one of those flukes, right? Something becomes unexpectedly energized or something to that effect, a car wreck down the street, right? Whatever the case may be prepared for the unexpected, okay? All right, thank you. Here's my contact information. If you have any questions, feel free to reach out, shoot me an email. I'd be glad to discuss with you or answer any questions I can. So, been a pleasure again, as always. And thanks to Brent and ECOS for doing this. I think it's a great cause. And thank you again.